Hello everyone, welcome again. My name is Amir Ahmed. This is my second live talk. This is the second live stream to talk about the Morpheus hotel envelope that I did with Rhino 7 and Grasshopper. In the last live stream we talked a little bit about the envelope complexity. We talked a little bit about the clusters, how we create them, how we store them to use them later, how to use them to organize our files, a lot of things like that. We talked how to do the structure, how to do the grid, how to do a lot of tricks and tips, and today we will continue this. Let me share my screen. Just a quick introduction about ourselves. We are Exact Architecture Studio. We based in Egypt. Recently we were working with so many different complex project, technical projects. Some of them like this. This is a technical project with dealing with structure. This is a grid simply. As you can see in here, this is a diagonal grid, and we wanted to create a structure out of it. This is a second example. Also, we worked a little bit on the facades, on conceptual design for facades. This is a quick, changes of the floors, quick animation for it. We worked also on a conceptual designs like this one with the students and architects. Also, this is the process we did with them. This is a little bit large project, mostly Rhino 7 with the sub-D technology. This is the result of it. It's an architecture project, full architecture. This is the conceptual structure and the basic sections to explore the concept. Now we are talking about the Morpheus. This is the example that I did in the first live stream. I talked a little bit about the envelope complexity, what the Zaha Hadid did, what Bro Hubble did, what Front did. If you missed that, you need to make sure that you watch the first live stream before you go through this, or simply you can go through this and watch the live stream after this, the original one. This is basically what I did. This is the full envelope. I did the cladding. Let me start from the right. This is the NURBS, the Rhino part. After that, I input it into the Grasshopper to make it a mesh and to extract the sub-D part from it. I turned it into glazing. I create a grid from the sub-D and use it to create the structure and the cladding. This is simply what you can. Let me zoom a little bit in here. This is the structure, and we talked in the first live stream how to make it, and maybe I can talk a little bit or make a recap about it. Also, we talked a little bit about the intersection between the structure. The structure is simple. The cladding is complex yet elegant, and of course there is some kind of a gap between them, and we needed to measure this gap to know if it's enough to fit the technicals. This is a little bit of fabrication, which we are going to go through this live stream. This is the fabrication also for the nodes, which is most complex. Also the parametric coding, we will talk a little bit about it. Now let's go to Rhino. Let's hide this for now. This is what we did in the first live stream. This is the original B-rips or surfaces. That's how I dealt with this issue, and we did a sub D. We transformed them into sub D. Again, I created multiple clusters. You can see them in here. I explained how I did them. I explained how I sorted them in the Grasshopper file, so I can use them. For example, if I wanted to use this one, you can see in tree branch. You can see it right in here. Those are the clusters that I did, and they are already sorted. If you want to know how I did it, you will find them in the first live stream. After we did this part, we separated it into multiple parts. Let's see. You can see in here I separated it based on their height, because each height will be used for a different pattern. And after that, we used different patterns of curves, like in this case this one, this one, this one, this one, and finally this one. Okay, after that, this part is basically just to make a sub D and make multiple offsets. Let me show you a little bit this one. And let me enable the clipping so you can know what I want to say in here. I created a multiple sub D layers. The first one is this is the original one. This is the glazing part, and also the reference that I wanted to orient everything to it and make it, make the structure respected, make the cladding respected. The red one is the layer for the structure, and the four other layers are for the cladding, because I wanted to create a chamfered cladding and smooth, so that's why I did 4 layers. After that, I separated the structure, the curves that I did. Let me hide this. Preview off. I separated the curves. These are the reference curves, which I will use for the glazing, which I will use as a reference to orient every curve to it and cut it. Also, these are the structure curves, and these are the cladding curves. Also, I explained them on the first live stream. From this part, I created the planes on the structural curves and used them let me go from the front. I created these curves to solve the intersection between the multiple curves that I want to cut, because I want the structure not to intersect with itself. And basically, these are the curves that I got so far. These are the structural curves, and from that, simply I created. Sorry, some of the clusters will take a little bit of time. I created a simple structure that respects the original the reference curves, just like this. You can see that each member of structure is oriented exactly at this reference curve, and from that I created the nodes, which basically I created these plans at the end of each structural member, and I created these curves from the plans, and after that I created these curves to after that transform it into the structural node, and you can see the final result. Let me show it in here. This is the final result for it. You can see that every element of structure is not intersecting. Every node is exactly fitting or maybe collecting the structure together. So basically that's what we explained in the first part. Now we are going to continue to go the cladding part. The cladding part is more sophisticated and more has a lot of tricks for its own. So let me open this cluster. Basically what you are going to see here, these are the 4 layers that we wanted to create, that we wanted to deal with, and this is the reference curves, and sorry, this is the structural curves. I selected the cutted structural curves because I already wanted to cut the cladding exactly where I cutted the structural curve in the first attempt. Okay, so now basically we want to make sure that each curve, let me explain what I want to do in here just quick. This is the structural curve, and this is the cladding curves. Alright, I want to pick this point and this point and to basically project it on those curves, so I can cut it, I can shatter them at this exact point. So that's basically what we are going to do, but unfortunately it didn't work very well, so I had to cut or split the tree of the data into each branch into its own. So as you can see, this is the first branch of data, this is the second branch, and this is the third branch, this is the fourth branch, and it's basically like this. This component is called split tree, this component called construct path. It's basically what this component do. This is the 0, and this is to make this arcs, so the Grasshopper will understand it. And let's remove everything. Again, I wanted to cut the curves of the cladding, which I will use them for later, exactly at the curves, exactly where the curve of the structure were cutted before. So now what I want to do is basically pick those curves, pick the end point of them, and use this to grab. Let me hide everything, just we can see. You can see that this layer of curves grabs this using this curve closest point, and after shattering them This is after shattering them. You can see that in here each branch has a one curve, but after shattering them you can see that each branch has a three curves, because it's 1, 2, 3. And again I simply sorted them by their length and picked the longest one. I explained this trick also in the first part if you missed it. And simply I did this for all the other three branches. So you can see in here also preview on. So now we have these curves, we have this structural curve, you have these 4 layers of curves, and they are exactly cutted with where I wanted to cut them. Again, this is just a trim tree. I explained what it does. In here you can see, let me show you just quickly. You can see that each branch has we have 1, 3, 2, 3. It's a lot of data tree that we don't want to deal with. In here we just simply created 4 main branches. We cutted the sub branches, and that's it basically for this one. And you can see in here I just make it a little bit shorter, just we can make sure that they are not 100% intersected at any point. When you are done with a simple cluster like this, or any cluster, it will reprocess everything. So if you are working in the beginning of your project, it's okay to save every step, but in this case I will not save any cluster, because it will take so much time to process again, and this is not what we are wanting to do in this stream. So unfortunately I will say discard and close, but to save some time. Okay, so basically what we got here, let me hide this, preview off. So what we got here is simply those 4 curves, and they are cutted exactly where this curve are cutted. Alright, now let me show you what is happening in here. This cluster, I explained it a little bit in I explained a similar cluster in the first stream, but I will explain it again. Just a quick explanation. These are the surfaces, all the surfaces that we are dealing with, and we are simply splitting the trees. So let me show you what is happening in here just quickly. This is the main after splitting. This is before splitting. Everything is in a whole branch of tree, a whole main tree. But now this is after splitting. This is the positive and this is the negative. So now I split this one like this. This cluster called custom path, I created it. It's simply just to make this called concatenate. It's simply just to create something like this. The star is just to make sure that ignore the second part, split this one, and whatever happens in the second branch or in the secondary branch, ignore it. Just bring me everything with 0, just like that. Of course we can't use custom because it doesn't work in this time. Custom path. Again, this is the negative. The negative is everything else. I wanted to separate the structural. I want to separate the structure part in here. So You can see in here, this is the positive, this is the negative, is everything else. So now this is basically what we did. What I did in here is just basically, let me show you. This is just to trim a tree because I don't want this to look like that. I wanted them to be only 4, but I used this tree branch, and I used tree statics, and I used the paths, and I renumbered them. Renumber because I wanted to change this from T2, 3, 4, 5 to 0, 1, 2, 3. It's easily to work with them like that. If you don't want to work with them like that, you can just you can just use this, but I prefer this way. And simply now we have the reference surfaces, and also the cladding surfaces. And again, I will not save. This is a little bit heavy. And here we go. Again, it's a lot of splitting trees because we want to deal with a specific data tree to do a specific task. Let me walk with this from here to there. Okay. If you looked in here, you can see that each tree has a specific curves related to it. That's what we are trying to do in here. So basically, if we want to do, let's say, tree branch multiple, I created this cluster too. You can check how I created in the first video. I want to use these. Actually, I want to use these and these. Okay, and I will say, let's say 80 or anything. And simply what we are creating in here, we want each surface to grab the nearest curve for it, because we want simply to offset each curves on its own surface. This way we will have the cladding curves without dealing with so many mess. That's what we are trying to do in this cluster. So basically what we did in here, let me show this. Yes, these are the curves, and simply we splitted them into multiple trees, multiple tree branches, just like this. And each tree branch, if we hide this, you can see that it's one branch in here. And this component called surface closest point, it's basically an attractor. So these are the surfaces. Also, I did the same thing with the surfaces. I deconstructed them and split them into multiple tree branches. So each face of this pyramid will basically attract the closest curves based on their buoyance. When you attract something, you attract it based on the point. If you attract a geometry, if you attract a curve, box, whatever you want to attract it based on a point. So you can basically finally cull it and separated them into uh, into into a specific trees. Each tree contains the surface, the closest curves, and this way you will be easy to deal with them. It's exactly what we did in here, and if we change the number in here, you can see that wherever I go, you can see that the curves are exactly on the surface, and this is really cool. But also it takes a lot of time to process because of this part, because you want to attract from a large data tree or tree branch, you want to attract something from it. And this is going to take a little bit of time because it's a lot heavier. It's, as you can see, it's 33% of the file. This is, I think this is the heaviest cluster I have in here. So if anyone have any questions, I will be glad to answer them, and just drop them in the live chat, and I will answer them during the stream. Like this cluster, it will take a little bit of time, so if you have any question, I will be glad to answer them. Or if you're watching this video after the live stream is gone, you can simply ask me in the comment. And we are waiting. Here we go. So basically what we are wanting to do in here, let me show you what we want to do. Let me hide the final results, preview off, and let me use, sorry, tree branch multiple. Quick tip: if you want to search for a component and you are kind of in a hurry, you just write the first two letters from each let's say a word. For instance, if I want to say tree branch check multiple, just TRPRMU, just like this, and you can simply find it easily. You don't need to, let's say if I want to deconstruct perb, you don't need to write deconstruct perb the full, but just like this, deconstruct perb, and you will find it easily. And in here, let's say tree branch multiple, and I want to check these curves with this surface, and I want a specific one, let's say 50 or anything, and I will hide this, preview off. And simply what we want to do in here, that we want each surface, each curve to offset on the surface, so it will not lose the curvature of the surface. I want the final cladding to be exactly following the sub-deform, so I want to offset exactly on the surface. That's why I used this component called offset on surface. Unfortunately, it's red because if you have, let me show you in down there maybe. What I want to say is, if you have something surface in here and some of the curve will be out of the surface when you offset them, this way he will not be cool with it, but I ignored it because I didn't want to deal with it. It's simply working. Okay, so these are the curves that you want to do. For example, another cool tip, just click on the cluster and click right click on the canvas and click zoom, and you will easily be zoomed exactly what you want to show or what you want to work on, because sometimes when you are working like this and it will be hard to maneuver around it. So just click on what you want and just zoom, and you can easily deal with it. Again, I did this. These are the curves, preview on, and these are the other curves. So you can basically or simply you can see that each curve, let me show you this, these are the original curves, and you can see, I hate when the graphic card do that. Yes, you can see that each curve are offsetted exactly the same distance, right and left on the surface. This is what we wanted to do. And again, some data tree manipulation, like in this case. In this case, it's it's each. Sorry. In this case, it's a lot of branches, a lot of elements, and only we have two elements in each branch. Again, this is just to make it easier and simpler to deal with. At some point, I wanted to join the curves because those curves were in a separate surfaces, but I want them to be a one full member cladding member. This is why I joined them. I selected them in here. You can see yes, those curves, I selected them and joined them before I worked a little bit more. And again, a little bit of extension for the curves, just to make sure that they are 100% not intersecting, just like this, because when you are dealing in a flat surface like this, it will basically deal with the intersection perfectly. So I wanted to a little bit just move them back. And this is what we did in here. Okay, in this part, these are the original curves. Let me tell you what happens in here. Basically, we wanted to grab for each curve, we wanted to grab the 8 curve around it, because we wanted to loft them in the next cluster. But again, we wanted to grab for each layer. There is 2 curves that they are offsetted already, and we wanted to grab for each curve the 2 closest curve around it, because some of the curves are offsetted in one direction some of the curves are offsetted on one direction of the surface, and it doesn't fit in the other part. That's what we wanted to do. So basically, we sorted their, just grab the middle, the midpoint at each curve, and sort them based on their height. So I grabbed those curves alone, and merged them together. and in this part I separated them based on their tree split, tree branch. So as you can see, it's 0 1 2 3 again. It's a matter of splitting trees. In this part I basically grabbed each curve, each closest curve, each curve to the main, each offsetted curve to the main curves. Let me show you in here. And again we need to hide this, and basically zoom. This is exactly what we want to do. Because when you join them at the end, this is what you got. You will get exactly 8 curves. Preview off this. Preview off everything. Just we can see what's happening. You will get exactly 8 curves for each member, and as you can see, this is what we are looking for to make a loft. Again, this is the part of the cladding, the members cladding. These are the curves. Unfortunately, I wanted to sort them around the circle, so I grabbed the. Let me hide this. And let's tree branch multiple, just to understand what's happening. And select the circle, and let's say 50 or something, any tree branch, and simply zoom and hide everything else. This is the curves that we want to loft, and these I wanted to loft them around a circle, and the circle will be fit. This is a circle fit. It basically grab a bunch of points and fit almost at the average of the points. So I wanted to create. Let me show you in here. So if I said list item, and I picked those, and again Control C, Control V, list item, and pick those. Sorry, let's pick this one, it will be easier. And in here I will ignore this, and in here it will be easier this way. And preview off everything, just show me this. In this case, you can see that if I said this is the first item, the second item, the third item is in here, the fourth item is in here, the fifth, it's not going to work in this way. So basically in here you can see it's simply the first, the second, the third, the fourth. It's working. You know, you can see it's a loop. we wanted to make sure that they are lofted exactly perfectly, so we grab sorry we grabbed the items and we shifted them and we grafted them. And so if we tree branch, if we select any branch like this and say for instance 50, why I keep typing 50 I don't know, but anyway, zoom, you can see that it's perfect. Just two curves, so it will be easier to deal with them. In this part I wanted to eliminate any cladding members below the earth point. So as you can see in here, let me show you this one just real quick. This is everything, and this is just without the parts that down here, because of course when you have a structure members that are inside the ground, you don't want to clad them, of course. Again, just a rebuilding for the curves, because sometimes they have a little bit of issues, and it's easier to rebuild them and simplify them before you loft them, because you don't want your model to be heavier than it is. And simply loft like this, and you can see that everything is perfect. This is the lofted items. These are just to eliminate any empty branches in the tree, because when you come in here and you will have some empty branches, and you don't want this in your tree. And also I renumbered them again because I wanted to make sure that the trees some of the trees are not perfectly renumbered, so I renumbered them, as you can see. And again, discard and close. And that's basically what we did with the cladding members. You can see that they are perfect. We can select any one, preview, and again in the canvas and zoom, you can see that they are perfect. And now we want to deal with the cladding nodes, which is way much difficult. Again, some of the clusters will take a little bit much time, and here we are. This is one of the coolest clusters, because when we are dealing with the intersections, it's important to understand how we want to deal with it, how we can grab everything in a specific space, and also sometimes we need to visualize for our eyes to understand it. So here's what we did in here. Let me hide everything in here just for a moment. And basically these are the original curves, and these are the cladding curves. I separated each two curves into a separate list called partition list. This component called partition list, I separated each two curves into that list. And what I did in here, just basically, this is the 0 and 1, 0 1 2 3 4. I don't want it to be like that, so this called path mapper. I change the 0 with the second 0, or the main branch with the second branch, so you can see it's like this, so it will be easier to deal with them like this. And again, if I said cut them, or basically trim tree, this is what we got. Let me show you what is happening in here. Tree branch. Okay, simply zoom. I don't like this. Let's say tree branch. Okay, let's say 50 or something. And this is before. Control C. This is what we have in here, and if I zoom, this is what we have in here. If I trimmed it, this what will we have. You can see I wanted to separate them into layers again. Just if you didn't understand this part, I wanted to separate the layers again, but from the new curves, because I wanted to create these. Let me show you in here. I wanted to create, and from the front, I wanted to create these green curves to cut, not to cut, to make a planes at these curves, and I wanted to use them. I want to use them to create something called bi-arc, and I want to use exactly those curves. So that's what, but I want to use each layer for its own. So that's basically what we are going to deal with. Let's preview this off. Let's show this and show this. What we want to do in here, if for example I want to grab these curves, each curve I want to create something called line SDL. Line SDL is a vector basically, or is a kind of a vector. I wanted to use it. So these are the curves and these are the curves. It's important to make sure that the start point of the curve is exactly at the end and the start, and the orientation is inside the curve, because I want my curve. Let me just quickly explain. This is my main curve. This is my main curve, and this is the point. This is the second point. I want my arc to start from here to here, but respecting the tangents. This is what we are dealing with in here. So this is the tangent, this is the point, and this is the line SDL. This is the tangent, this is the point, but in this case, if I insert this one like this, sorry, I shouldn't done that, but basically it will create the same curves, but exactly in the opposite in the positive direction, which we don't want that. You can see them in here. That's not what we want to do, and basically just We will undo that just quickly. And we are back, and just like this we again let me hide this, and let me hide this. So now we have the intersections and we wanted to deal with them. Of course I want to deal with them exactly. I wanted them to intersect, so I extended them a little bit, because I wanted to make sure that everything is intersected for the next part. Again, I separated them based on their let me show you in here. These are the original curves, and these are the end points of each curve. These are the reference curves, the reference layer, as you can see in here. And I grabbed the end point of each curves, and I removed the repeated points or the duplicated points, because I don't want, it's already a heavy cluster, and I don't want the processor to go through a lot of unnecessary points. I want exactly, as you can see in here, this is like 2648 points, and after culling or removing the duplicate points, it went to 562. It's almost like the quarters or something. Again, I wanted to grab the curves around each point from a separate layer, so it will be easy to deal with them. Again, I separated the layer. I measured the distance between the end. This is, let me show you this. These are the curves, and this is the end point, the start point. You can just simply click the start point, but in this case I choose a point on curve, and I measure the distance between each point and all of the start points on this layer of all of the curves on this layer. And if the distances were a little bit less than 1.7, okay, those curves I wanted them. So to see what 1.7 in a huge example like this looks like, I created this mesh sphere just to visualize everything, and this is basically what we did in here, just to know, to make sure that the points that we are talking about is exactly inside this mesh sphere. So if they are not inside the mesh sphere, that is a problem. We don't want to deal with it. Okay, so that's basically what we did in here. And again, we just culled the points. We just cut the points and used a group command. Group command is just to make sure that each tree branch has each tree branch has its own group. And that's basically it after grouping. Why I grouped them? Because I wanted to merge them, and unfortunately when you want to merge something like this, the first tree of each branch will be merged together. So I didn't want that. I wanted them to merge, but at the same time I wanted them to be as a separate group, so that's what we did. And now the fun cluster, where almost every let's see, this is where the magic happens. Again, it's a little bit heavy. You can see they are looking already good, but we will understand why they look this way. Preview off and start from the beginning. These are what we are dealing with right now, and as you can see, each in here we are just ignoring some of the, what's this? As you can see in here, we are just ignoring those parts because we didn't want to make a cladding node out of them. So in here we just ignoring these members. It's just a culling part. And again, when you cull stuff like this, you will end up with some trees that have no elements in them. I don't know if it will be easy to find one in here, but basically you will have a tree with a 0 element. I don't want to see that in my script, so I just clean the tree with inverting the remove empty to true to make sure that every empty branch is removed. Again, since they are all lines, I wanted to make sure that they are not repeated. Sometimes you need this this component, sometimes you don't need it, but just in case. And extended them, but I extended them back. In the previous cluster, we extended them 1 meter inside just to make sure that they are intersecting, and it will be easier to measure the points in a specific area inside the mesh sphere. So now I return them back to their original status. And in here I just simply made sure that they are sorted around the circle. These are the circles, as you can see, but I sorted them from the out points, from the end points, just to make sure that they are exactly they are sorted exactly. Let me show you in here. Let me copy this. Control C, Control V. I created this previously. It's just to make sure that everything is working. And as you can see, let me pick one tree branch. Let's say 40 or anything, and just to be not confusing, preview off and simply zoom on this, and from the perspective zoom again. You can see these are the one that we are dealing with, and simply we want this to be like to be sorted like this, because I wanted to pick each two curves and make the arc between them. But in this case, as you can see in here, this is a perfect example actually. In this case, the curves are parallel. I don't want to deal with the curves if they are parallel. This is not what we want to do, because simply we want to create a curve in here, again a curve in here, a curve in here. So this is what not we want to do. So I had to do this. This part is basically telling him, okay, now I want to let's say we will dispatch, so it will basically create the first item, let's say the odd elements and the even elements, each in separate branch, and I wanted to create the angle between them. And if the angle irradian, I transferred it into degrees, so it will be easier to me to understand it. If they are smaller than 15, why 15? Because the closer to 0, sometimes it will ignore some of the curves, and still, because some of the curves are not on the same plane, so it will not be easier for it to calculate. So in this case, we wanted to make sure that there is a range of variety. So that's basically what we did. Let me show you here. So these are the curves. Let me go to the front. It will be easier to see them in here and show this. So this is before. You can see some of the curves are parallel, and this is not what we are looking for. This is not good at all. And after, you can see that each two curves are not parallel at all. You don't want to be confused because of this. Maybe I can go to the perspective, go to this, enable it. Just can see, and actually from the front and you can see it's exactly perfect. You can now perfectly do the pi arc component. Just to make sure, these are the first two curves, the second two curves. I changed the index of this from normal to even, so it will be 0, 2, 4, 6 like this. You can see it's perfect. And preview off. Now the magical part. The magical part is we want to, let me Control C, Control V, and let's get tree branch, any tree branch, for instance. And list item, and again let's copy this one. It will be easier to show in here. Okay, let's hide everything and simply zoom to this. Hello. If you want to zoom like this and there's nothing happening, that's because it's behind the clipping plane. Okay, and simply zoom again, and you can see this is exactly what we want to do. We can change this to 40 or something, and simply zoom again, and you can see this is what we want to do. Basically, again, this is the magical component for the cladding. It's basically you want you create a point and you have the tangent, and you want to make sure that the tangent sorry the the tangent of the arc at the start point is exactly the tangent of the of this line at the end point. And this one again, actually those are the start points, sorry. And in here I had to reverse it, because if you didn't reverse it, it will be like this. It will start in here and end in here, and this is the ratio. If you want to manipulate it, let's say 0.25, you can see that it's kind of fun to play with, but in this case we didn't want to play with, and we kept it the original because we wanted the curve to be like this. And simply if we moved around, you can see this is exactly what we will get. So that's what we did in here, but of course we did it in a large tree branch. So this is the final result, and these are the original curves. In here what we did is just simply create lines between them to just make sure that they are closed like this, and merged them and joined them. And actually after joining them, some of them weren't closed, so I had to dispatch them based on their closeness, this component, just to check if the curve is closed or not. And if the curve is not closed, I told them, okay, let's zoom, for instance. Those curves, especially at the top, were not closed. Let me show you the original curves. These are the original curves. Were not closed, so I had to make sure they are closed, so it will be easier. Preview off. What's happening? Okay. So I had to make sure that they are closed. And again, these are the curves, the arcs actually, and I join them with these curves. This is after joining. This is the lines that we created from this part, and this is the curves. Why I did this? Because simply I wanted to again and simply just split the tree again. I wanted to create to deal with each layer of its own, so simply I separated them. And again I preview on, just to make sure that everything, let me show you this one in here. Let's just preview off everything because we don't want to be confused. It's really important when you work in a large complex technical stuff like this to be organized as much as possible, because you will lose concentration, you will lose track of things. You know, if you want to edit something, if you want to maybe improve something in the future, if you want to hand it to a colleague, it will be so much harder to deal with something like this. if it's messy and not organized and not clustered. Actually, if this file is not were not clustered, even if it's organized, it will be a huge file, and it will be like nightmare to deal with. So again, this is the first layer, the second layer, the third layer, the fourth layer, and in here I collected the closest points. Why I did this? Basically because I want to grab each point of these. I want to loft them. So if I set tree branch in here and I selected one of them, actually I will select one from here, and I will say simply just 80 or anything and zoom. You can see that this will be easy to deal with. This is exactly what is happening in here, and this is just to make sure that each curve will be exactly at the orientation of the curve before, because some curves will be in the same directions. So if they are in the same direction, the loft will be good. If they are in the opposite direction like this, the loft will be twisted. So this is not what we want to deal with. So simply I picked the curve and I said, okay, make sure that the curve is the shifted list is flipped based on the original geometry. So he will see which point is closest to the start point of the original curve, and if it's the start point, it will keep it as it is. If it's the end point, it will flip the curve. And this is, where are you? Zoom. Again, after shifting and after grafting and all of these things, it's important to simplify as much as you work. It's important to simplify the tree, so you don't have so much unnecessary branches, and also sometimes some of the branches are having unnecessary sub branches, and when you merge them with another branches, it will not merge correctly as you wish. So it's important to simplify when you are going or working. Try as much as possible to avoid the flatten component unless it's absolutely 100% you need it. Unless you need it, don't use it at all, because it will mess your data tree. In large projects like this, I almost use it in a little places. Okay, now we are back. Again, we did them as groups, and we just picked the curve middle. Let me show you what's happening in here and in here. We called the group based on the we of course we don't want any groups to be duplicated. If there is any unnecessary curves, we don't want that. That's what we did in here. And of course this is just 2. If the list length is equal to 2, bring it. If it's not equal to 2, if it's more than 2 elements or if it's more than 2 elements, or if it's less than 2 elements, I don't want it. I wanted the list length of me the list length of these curves to be exactly 2, so I will make sure that they are perfect. Of course, when you do things like this, you will have some zeros, as you can see in here, and you need to cut them to clean the tree. And just basically you can rule the surfaces just like this. So this is basically the out part. Now I will deal with the surface, the main surface itself. Now let's go back, preview off, and maybe we'll keep this. Okay, and we will go back in here. After we did the pi arc and we created these lofted surfaces, and of course we created, after this we created we checked if they are closed or not, and this is what we have so far. Okay, again I have in here, let me show you a tree branch. It's important to organize your data, to organize your tree, to make your tree simplified, to make your tree to understand how to check on yourself. So this was what is this component for. And just let's say 90 or whatever. Zoom. So as you can see in here, there are four elements or 4 items in this branch. As you can see in here, this is the 90 and this is not 90, because basically this needs to renumber, but in this case I didn't need to renumber them because I renumbered them ahead in the, I think, in the next cluster. Okay, so all I needed in here is just the first one, list item, the first face and the last face. Maybe I could just do this. This is if I hit the plus above the item, or it basically give me the last item. This is a great trick. Or I can, since they are 4, I can do them like this, but this is helpful in most of the time. But of course I can't save this now because it will take some time to process, which I don't have. I don't need it right now. Again, now I want to make, I just exploded them, and after exploded them you can see that each branch, the 0 has 0 and 1, the 1 has 1 and 1, the 1 has 0 and 1, and so on. So this is really great component called batch, and it's a little bit heavy. It's one of the heaviest components. As you can see, it's 79% of the cluster. Basically what this component does is grabbing the curves from here and try somehow to create a network between them, and simply you want to create a network between them, network curves, and in this case it's 10 by 10. You can put a tolerance on it, but in this case it's 0.001. It's like a millimeter or something, and this is actually pretty cool, especially in these parts, because some of the nodes, as you can see, will be twisted or modified somehow, so it will follow it. It will be easier to see in here. It will follow it exactly. This is pretty cool. And again, just merging them to make sure that they are in one branch, just like this, and say 50 or something, and simply zoom, and you can see that each node will be merged together, the lofted surfaces, the original surfaces, everything. And just after explosion or deconstructing the node, just to make sure that each branch will contain exactly the batched surfaces, the original surfaces, everything. And it's important to understand the data tree organization. In this case, I put it the batched surfaces the first, because when I want to deal with the fabrication, I will pick the first and the second item in the tree, which is basically those batched surfaces. I want to deal them in a specific way, and the rest of them I want to deal them in another way. So that's what we are dealing with in here. So it's important to organize your thoughts, to organize your data, so it will be easier to deal with them. Again, close. And as you can see in here, let me show you simply. This is the cladding. Hello. Yes. This is the cladding. You can see that it's perfect. Each node is perfect. Each member is perfect. This is just to visualize, not this one, sorry. Yes, this one is just to, make like an line around it. Just grab the curves and just make a shading around each part, just to make like an eyeliner or something around each part. So that's basically what we had to deal with the cladding part. What we explained the exoskeleton in the first part, and now the cladding part. After that, maybe we can simply this cluster. Let me hide everything in here. Preview off. Actually, let me preview on this. Yes, so that's the original sub D, and the structure inside, the cladding and everything. Now all we need to do now is just check the intersection. Just select this and zoom. Where are you? Yes, you are here. This component is basically pick a structure. This component is basically picking a curve and pick the structure around it and the cladding around it, and of course based on a specific numbers, this will be the item index, and this will be the evaluation where I want to search exactly. And let me hide everything in here. Preview off and preview off. So What is happening in here is just picking the curve, picking the structure around the curve, picking the beer around the curve, and this happening basically because we made them as a group, and after we made them as a group we just select the the point of each group and make sure that each group will get the average point. So this is a cool component called center. You can simply find it in just Control Alt and click, and you can find it in here. It's Heteroptera, and it's in geometric in here, and you can find it, or you can simply just type center. If you don't have this plugin, it's important to download it. It's really cool, have a lot of cool components. Review off. And after that, just closest point to grab the structure, closest point to grab the cladding, and after and these are what we are dealing with. And simply, when you have a curve like this, you want to check the where you want to create an intersection between them. Preview off. Again, preview on. You create a circle like this, and after you create a circle, you simply just make a pair intersection between the structure, a pair intersection with the cladding. Preview off, and just basically you can preview on this now. So this is what we have so far. It's important to visualize your data so it will be easier to read. In this case, I just this is called custom preview line weight. I just created this with blue. This is the structure. I created it with red. This is like an off-white, and with some edges to show it better. Preview off. If we did it like this, sometimes it's not pretty clear. Of course, you can visualize however you are or you wanted. Preview off and preview off. Yes, it will be like this, and it's not clear, so sometimes you need to show the curves. And that's basically this component. No. This component is very cool because just let's zoom in here. This component is just to orient everything we did. As you can see before, we did exactly the same thing in here. We grabbed the structure, we grabbed the elements, we grabbed everything, but after we did this, we oriented them, and we oriented them exactly from the initial planes, which is the circle, or you can simply select the frame, whatever. They are both the same. And after the orientation, you can simply explode. Preview on. You can simply explode all of the curves and make sure that they are all joined. And there is a component in here called curve proximity. Curve proximity is basically just creating a line at the minimum distance between the two curves. In this case, this curve and this curve, this is the minimum distance between them. This curve, this is also the minimum distance. If we change this, let's discard for a second, and what's happening? Yes, let's preview off and preview this on, and yes. So if I change this number, you can see there's a number in here appeared, because this curve, for instance, this is the minimum distance, but in this curve this is the minimum distance, in this curve this is the minimum distance, and in this curve this is the minimum distance also. So they are two dimensions above each other in here, but it doesn't matter in this case because it's just for visualization. This is exactly what's happening in here. And again, after orientation, you just want to visualize everything, and this is just an aligned dimension from the first point to the second point, and you can select the offset and the size of the dimension itself, and just like this. So this is for this part. This is just to check. Again, we want in here, of course, the members of the structure, the cladding of it. We want to fabricate it. So first of all, we need to seek it, to search for it. So simply we are going to zoom in here, so we will know where is this member located. And after we see it like this, we are simply preview on and zoom to this member, and you can see that it will be fabricated automatically. This is a cool part. And of course, if you change this number, let's say 65, let's say 73, whatever the number is, it will be fabricated perfectly. Even the twisted parts, it will be fabricated on a sheets like this. Of course, in real life, you have a specific sizes for the sheets, so sometimes you need to deconstruct it even more and split them based on you know, this is maybe a large member, so you need to split it 2 or 3 sub parts. But anyway, let's go inside and see what's happening. In here we are just selecting a specific member, and just to in here just we are orienting it like this. Let me show it in here. This is the member that we are selecting. These are the full members. We are selecting a specific one, and we are oriented it to the XY plane. How we did that? This is how we did it. Sorry. Yes, in here we selected a specific face, and we exploded it. Let me zoom on this. Yes, we selected a specific face, we zoomed on it, and after we zoomed on it, we sorted the curves. So it will be so we will pick the curves, the largest curve, and in here we created a plane between 3 points. You can see the plane in here. And from this plane, let me show you this one. Just this is the middle curve, this is the second curve, and this is the center of the geometry. These are really important. And we created a plane from them. Why isn't showing? Zoom. Yes, that's after the orientation. Sorry, that's the plane. Anyway, we oriented them to be exactly at this part like this, and after this we just created a bounding box around this part and deconstructed the box, sorry, enable, and moved this from this part to the 0. This is what we wanted to do, because we wanted from the front. Let's go to the front and zoom. We wanted to move all of the member above the 0, just for visualization purposes, because we wanted everything to be above the ground. And again, after moving, preview on, this is just to move. I moved it a little bit to the right just to be in the middle of this part. Let's preview off this. So this is what we did in here, and we moved it a little bit in here. So that's the second move. And after that we wanted to explode. These are the surfaces we wanted to create, to make them looks like they are exploded. So what we did in here is just simply we created a center point for everything. So basically he will get the average of all of the centers, and again we created an evaluation for all of the surfaces, and to get the center point of them as well. Preview off, and now maybe you can see them. Let's zoom. Sorry, that's a vector, you can't see this. Actually, I will create a line just to see what's happening. The shortcut for line is LN, because you don't want to LINE each time, especially when you have so much components. You can see that these are the vectors that we are working on, and as you can see, I told him, okay, move everything to this vector and move them a little bit up. So that's basically what's happening in here. And after we did that, we just got the edges, and in here these are the visualization part. Again, you need to be organized, because as you can see in here, it's a lot of surfaces, a lot of components, and you need to be understanding what you are doing. These are the parts, and we wanted also to simply create a mesh out of them, and simply, let me just for a second, there is something wrong in here. Should be like this. Well, it shouldn't be like that, but I don't know why it was working. Let me check again. Alright, this part is not working 100% perfect, but let's ignore it for now. I will explain what's happening. In here, as you can see, we are simply creating an illusion. Preview off. We are simply creating an illusion of a curve. We are creating an illusion of a surface, and the more this part, let's say 50, the more accurate the surface will be. And again, we wanted to make sure that the mesh direction is all of them will be the same direction, and just simply unroll them. The unroll part is very cool because simply you are making it flat instead of ruled or bended. So let's say 0.25, just to show you what's happening. You can see that the more from the 0 is unrolled and 1 is totally rolled. And again, this is the edges, and after rolling them they can be surfaces, and simply orient them to be like this. And after orienting them, we can start the open nest and insert them inside the open nest. But before we do that, we need to create the sheets. So preview on, these are the sheets. This is the starting point, is just the basic point, the origin point. And in here we wanted to create them with this length. I picked the length from here, from these parts. I picked this length. Preview off, and let's zoom again in here. So this is the grid, that the sheets that we want to fabricate on, and this is the just offset for them. So that's basically preview off. These are the sheets, and preview on this to show you what's happening in here. Preview on. These are just lines to make sure that, let me show you this. These lines are just to make sure that to create some kind of a vector to write the code on it. And so again, this is the point in here, the center. And again, I moved it a little bit up and a little bit down. I created a line. I grabbed the points from each surface to create a second line like this, and a little bit of extension like this to create a plane between this line and this, a plane between these lines. And the original line this. So let's hide everything in here, preview off, and after that this is the planes that we want to type on it, preview off, and as you can see everything is related to its surface and ready to write on. Preview off this, preview off everything. Just show me what's happening in here. Zoom and zoom, preview on. So I created this just to check. Alright, there's something in here, preview off. I created this just to check that this one with code, this one is with code 431R will be this one with code 431R 43. And if we changed it like this, zoom, you can see that whatever we will pick, it will be exactly the same. Alright, now we need to see where the coding happens. Here's the part of the coding. It's simply, let me show you what's happening in here just real quick. This one is grabbed from this tree static. So this is the node number 43, okay, and I want this part to be the first part, and after that I left a little bit of space to be read exactly as possible. I don't want all of them to be just without spaces in between. And after that I grab these are just the 1 2 3 0 1 2 3 4 until 8, the item index, and after that I just grab the R because they are ruled surfaces, all of them. Maybe I don't need to write an R, but just in case you are working on a complex things. So this is basically what we have so far. So if we looked at here, you can see that this is the parametric part, the parametric coding for this part. Whatever we are looking at, you can see at the end that this is will change automatically. So if we say discard for now, and for instance let's say 78 or whatever, you can see that the code is automatically changed. Like in this case it's 78 and this surface is number 5, and you can see it in the fabrication sheet. Let me just go in here and just adjust this because it was supposed to work like this, and in this case let's say 1, and this one will be work perfectly as you can see in here. And discard and close. Actually in this case we need to make it a little bit larger. The size in here will be like 4 or something. Yes, so everything will fit inside. And save and close. Okay, now we are working. Now we will work on the fabrication of the nodes, which is way much difficult. Again, we will preview on and zoom. Let's see which node are we working on. This one what we will work on, and simply we can just go in here and zoom to everything in here. When you have your file like this and looks weird, that means that your Z direction is not working, is not oriented to up. You need to flip your file like this and it will be working pretty cool. Okay, in here we have a lot of things going on because it's way much complex and way much details to fabricate and to consider. In this case, we have this node, which is basically this one, and simply again we just oriented it to the 0, and we are moving it a little bit up, and just like that. Again, we will separate the surfaces just like this. Let me hide this just for a moment. Preview off, just we understand what we. It will be easier to see what's happening. All right. So this is the original nodes, the original node cladding. This is the unrolled part. It will be easier to unroll this. This is just to explode it a little bit. And this is just as you can see, the mesh is working here pretty cool. This part is basically the same this part is basically the same part as the previous one, with the cladding, with the member cladding, because it's basically a ruled surface, and it's almost the same techniques. Even this part, as you can see in here, and just to orient it on the ground, and after that you can basically just simply not this one, sorry, yes, in here, simply just fabricate it like this. And this is for in here I culled the first and the second part, the first item and the second item, because they are not not ruled surfaces. I wanted to collect only the ruled surfaces and work with them. In here I picked the first and the second element, which is basically those, and in this case they are way much difficult to work with, and this is just to sort them based on their height. And in here just moving, just quick workings. Alright, and here this is just this part is just for the parametric coding. It's basically like this. We had to explode it. We moved it like this, and after that we moved it again like this, just to make sure that they are almost at the ground. Some of the steps you think it's unnecessary, but when you are working, you want to do it because you want to visualize your work as much as clear as possible. Again, after this part comes the magic, because I dispatch those bashed surfaces. Basically, if they are planar, you can simply laser cut them on a flat sheet, which is what's happening in here. Sometimes they are planar. If they are non-planar, you need to do some work with them, and as you can see, you can just project them on the ground and simply loft everything in here. Preview off. I don't want to see this. Okay, and after that you want to create a grid. Create a rectangle to fit everything inside, and divide the rectangle like this, and simply creating a grid. Let me show you in here. Yes, to make sure that to create lines like this and lines like this, and to extrude them to up. Preview on, preview off. And after you do that, you want to get the intersection between them. You can see it inside. Get the intersection between them, and the fabricated part, you get the intersections, and after that, preview off, you make them sheets just like this, and you can see that they are having waves according to their orientation. Of course, you can work on them more and create solve the intersection between them, but in this case I had enough with this example. Enough information. This example I worked on because I wanted to learn how to create or handle such a complex thing like this. Again, we are just creating some grouping, some tree trimming, and merging everything in here, so you can see that this is what we have so far, and this is what we created. Okay, after creating these, this part is for the parametric coding, but it's way much complex than it seems, because as you can see, this is the node, this is the because we have so much elements to deal with, so that's basically what we are doing. This is the first part, this is the second part, this is of course there is spaces between them, and then there's a lot of indices, list indices, and this is a cool element because it's working on a stream gate. It's kind of an if, you know, the if statement. If you are a coder or working with C# or Python or something like that, you need to make sure that to understand this. Maybe I will explain it later because I'm running out of time. But this basically works pretty fine in here. And this is the curves. These are the other curves. These are just for just for visualization. Again, this is preview on. Simply these are the fabricated simple parts. Preview off. Again, I organized them in here just to understand which part is going where. And preview on, and you can see this is what we got so far. So this is a batch surface, so it's basically 7.1b. You can see it in this is the fabrication of it. You can see any part in here, 712R. You can find it somewhere in here. You can simply, let's preview on, zoom like this, 7.1R. You know, it's easier to work with them like this. Preview on. You can see this one is right here with the code of it. Of course, I didn't put the coding in here because it will be like a nightmare of coding in here, but you will get the idea. So basically that's it for the cladding, and of course, if you want to understand the structure is already explained in the first live stream. The importance of the clusters, the grids, everything else. Otherwise, it's just basically in here is visualization. In here it's just basically a moving for visualization, moving part. It's a little bit heavy, but it's not complex at all. And now it's hanging. Alright, as you can see, just moving things. Unfortunately, I don't have much time to explain the glazing, but the file is available for purchasing. If you are interested, just DM me on Instagram, or write a comment below, or you can contact me on my email or Facebook, anywhere. And also I'm working on a workshop which will be available soon. This is sorry. This is basically the workshop that I'm working on. It will be a sub-D tower, a complex tower with multi-cores and complex geometry. With I will try to push it as further as much as I can, so it will be an interesting workshop, and it will be available soon. This is just a quick animation that I was working on. And thank you everyone. I hope you enjoyed this live stream, and don't forget to subscribe. And if you have any questions, please let me know it. And also please go to the first live stream first, because you will miss a lot of information and techniques and a lot of that. Thank you everyone, and have a nice day.